No, projectile is a body which describes displacement simultaneously in two different directions, two mutually perpendicular directions. I repeat, projectile is a body which describes displacements in two mutually perpendicular directions. So here we have two types of projectiles. One is oblique projectile and other is horizontal projectile. Horizontal projectile is the body which is projected horizontally from certain elevated position. So, oblique projectile is any body projected at certain angle with the horizontal, either from the ground or from elevated position, will be considered as oblique projectile. All the fundamental definitions and all, the distance of the point where it strikes the ground from the point of projection, that is called as range, and the time of flight is the total time taken by the projectile to reach the ground. So there are small definitions. Now I'm just going to touch a few important things. First of all, the theory we need not bother much. So first of all, the trajectory of a projectile is given by tan theta into x minus g by 2u x square into x square, and we call it as ax minus bx square. So from this we got h is equal to a square by 4b. This is nothing but uy square by 2g. uy square by 2g is u square sine square theta by 2g. How I get this? Here tan theta is equal to uy by ux, ratio of components of velocities. So if you substitute in this, b is nothing but, it's there, g by 2ux square. So if you substitute in this, we'll get uy square by ux square into 4 into g by 2ux square. So this is how we'll get uy square by 2g. So that's nothing but the maximum height. Similarly, range, it is the actual formula you have studied is u square sine 2 theta by g. This is nothing but 2ux uy by g. So here you will get it as a by b. A is nothing but tan theta. Tan theta is uv by ux. B, g by 2ux square. So that's how we'll get a by b is nothing but range. Then if you need the initial velocity of projection, if the given equation is in this format, then you can write it as general formula a into 1 plus a square by 2b. Because a is equal to g on the earth, so you can replace it with u is equal to root of g into 1 plus a square by 2b. So this knowledge will help you to solve the questions if the equations given in the problem are in these formats. So let us try one model on that. Just you please note it, man. This formula is important. Other things you may be knowing, h is equal to a square by 4b, r is equal to a by b, and all you may be knowing. This is rarely seen. So u is equal to root of g into 1 plus a square by 2b. Here a is nothing but tan theta, b is nothing but g by 2ux square. Here ux is nothing but u cos theta, uy is nothing but u sin theta, the two rectangular components of the projectile. Now we'll do a simple model based on this. Standard model only. Y is equal to root 3x minus x square by 20. So here a is equal to root 3, b is equal to 1 by 20, h is equal to, it is a square by 4b, a square 3 by 4 into 1 by 20, 15 meters. Range a by b. So it is 20 root 3 meters. Plus velocity of projection, it is g into 1 plus 3, 1 plus a square by 2 into p, 1 by 20. This whole thing is under root. Let us take g also 10. So you'll get 20 meters second inverse is the velocity of projection. And t is equal to, of course, 2uy by g. U and ux are there, or tan theta is there. So from that you can get uy and solve it. So this is one model. Another model, the trajectory of a projectile is given by x is equal to (40t) 4t, y is equal to 3t minus 5t square. So you can compare it with, because horizontal component of velocity remains constant. So x is equal to ux into t, and y is equal to, it is uyt minus half gt square. So time of flight 2uy by g. So it is 2 into 3, 6 by 10, 0.6 seconds. Maximum height reached uy square by 2g. So uy square 9. 0.45 meters. Range 2ux uy by g. So it is 2 into 3 into 4 by 10, 2.4 meters. And you may have learned also the relation between height and range. That is, h by r is equal to tan theta by 4. And maximum range is for 45 degrees. So h by r maximum is 1 by 4. So theta is 45 degrees. Range will be maximum if the body is projected at an angle of 45 degrees with the horizontal. They're all standard things. Only the important formula which you might not, some of you might have seen, is u is equal to root of g into 1 plus a square by 2b. Rest of all the things are okay. Please note down. So the trajectory of projectile can be given either like this or like this. Manaswini late ma. Okay, no problem. If I waited, in fact, and then we started the class, no issue. Okay, now let us do another important things. Even complementary angles of projection also scope is there. Normally, projectile is linked with electrostatics. That part also I'll touch because already you have the knowledge of electrostatics. Radius of curvature, this is important point. Of the projectile path. So, in fact, we can do it in circular motion, but we may skip it. Circular motion, normally we don't come back to projectiles. So here, is the XY plane. This is the projected body. It's some initial velocity u or v naught. And this is v naught x, v naught cos theta. This is the perpendicular component of acceleration to the direction of velocity at the highest point of the projectile. And v naught y is equal to 0. Highest point, vertical component of velocity becomes 0. So here the whatever gravitational force is acting on the projectile will be the centripetal force. Normally, isolated concepts will never come in the exam, mixed conceptual only. Hoping that you are thorough with all the things, basic things. I am taking the liberty of linking the things. So Fg is equal to, it is centripetal force, which makes it to describe circular path. So here I can write it as mg is equal to m v naught square by r. Therefore, this is a simple concept. R is equal to v naught square by g, standard formula. So R can be also written as v naught square cos square theta by g. If you are comfortable with u, then u square cos square theta by g. Now the next one is little stress is to be given because of its differential calculus method of solving it. So we are going to get the radius of circular arc of the projectile. Okay. So here, imagine this is a circular arc. Suppose the projectile is moving like this, and the length of this circular arc is ds, angle subtended at the center of this circular path. The body may not move completely along circular path. So, portion of the path, whatever path, that may be the portion of a circle. So, here we know r is the radius of this circle, and ds is the arc length, and d theta is the angle subtended by the arc at the center. Therefore, you know very well, length of the arc is equal to r into d theta. Therefore, the radius is ds by d theta. You call this as equation 1. So this can be rewritten as ds by dx into dx by d theta. It's all mathematical interpretation. This you take it as 1. Then, you know, the displacement is the resultant of x and y components. So in the second step, ds can be written as root of dx square plus dy square. Now I am taking this dx square out of the brackets. So dx into root of 1 plus dy by dx whole square, or we are getting ds by dx first. So ds by dx is root of 1 plus dy by dx whole square. Then in mathematics we have a concept, slope is equal to tan theta is equal to y2 minus y1 by x2 minus x1. So this is nothing but dy by dx. So this is also represented as y dot. So I can rewrite it. It's also represented by m. So I can now write finally ds by dx is root of 1 plus m square, or it can be also shown as 1 plus tan square theta one plus y dot square. It can be represented in any of these formats. We call this as 2a. If you remember the final result, that's good. My tendency is not to ask you, give the formula and ask you to muck up the things. That's why I'm showing you this. So next one is slope. Slope y is equal to dy by dx is equal to tan theta. So now you differentiate once again. D square y by dx square is, sorry, secant square theta into d theta by dx. So this secant square theta can now be written as 1 plus tan square theta into d theta by dx. So now it is finally coming out to be, we want dx by d theta. Here I want dx by d theta. So this will be finally coming out to be 1 plus dy by dx whole square by d square y by dx square. Please check. This you call it as 2b. So ds by dx we got 2a, dx by d theta we got 2b. So if you put it in this one, you will be finally getting the expression for radius. Please note down. Note down fast. A very important expression is, final expression is to be remembered. Other things you can skip. But somehow I don't like to, remember this formula. I cannot do that. Completed, huh?
Completed, sir.
Good. So we'll get finally this 1, 2a and 2b. Finally imply as the radius of the curvature of the circular path. Yes, ds by dx we have 1 plus dy by dx whole square, of course to the power of 1 by 2, then d into dx by d theta. This is 1 plus dy by dx whole square by d square y by dx square. So final formula for R, it is 1 plus dy by dx whole square to the power of 3 by 2 by d square y by dx square. This is the final expression. You can represent in simple format. If you are confident that slope m is equal to dy by dx, then it can be also shown as one plus m square to the power of 3 by 2 by d square y by dx square. Or normally this y dot concept will appear in Irdov books, Russian books. So 1 plus y dot square to the power of 3 by 2 by d square y by dx square. So it can be shown in any format. If the second derivative is shown with double dots, it can be shown as y double dot.
Completed, sir.
Yeah. So this is y double dot. So second derivative of y with respect to x is shown with y double dot. Final result is important. Other things, the derivation part, yeah, you can just ignore. You can practice once and leave it. And one more thing, the radius of, because earlier we referred about radius of curvature. Now we got the radius. So I'm trying to give the clarity between both. Radius of the best fit circle. This circle is called as oscillating circle. This is called as radius of curvature. So what you mean is, this is a curvature and this is the best fit circle. So the radius of circle is, you can call it as R naught, and the radius of curvature, something like this, that can be shown as small r. Second point in the note, the curvature of a curve at a point is equal to the curvature C of a curve at a point is equal to the rate of rotation of the tangent. In mathematics, you might have learned about this with respect to arc length. Of course, specifically at that point. So mathematically, it can be given as d theta by ds, because we got one term there. Yeah, here before we go into the derivation, we got ds by d theta, the reciprocal of that radius, whatever we have shown there, will be d theta by ds. That is called curvature. Next question. Finished, ma?
Yes, sir.
Okay. Two bodies were thrown simultaneously from the same point. Standard concept. Two bodies were thrown simultaneously from the same point, one straight up and the other at an angle of 60 degrees to the horizontal. Both with the same velocities, each equal to 25 meters second inverse. Neglecting the air drag, find the distance between the bodies. 1.7 seconds after their projection. 1.7 seconds after their projection. So first one is V1 bar is V0 J bar. V2 bar is V0 Xi bar plus V0 Yj bar. And the displacement is distance between them. Okay. Or the displacement between the two positions after the given interval of time is relative velocity multiplied by the given time interval. So it is V0 J minus V naught cos theta into I plus V naught sin theta into J multiplied by T. So this is of course V2 minus V1, so you'll get minus here. And here it becomes plus V2 minus V1. That is more correct. So we will be getting magnitude of displacement will be finally coming out to be V naught T into root of using that AXI plus AYJ, then mod A is root of AX square plus AY square. So using that, finally I will be getting it as, yes, it is V naught T into root of 2 into 1 minus sin theta. So it will be minus V naught cos theta I minus V naught into cos theta I plus 1 minus sin theta into J. That's how you'll get final expression. So AXI plus A by J means mod A is root of AX square plus AY square. So that sin square theta, cos square theta, sin square theta plus cos square theta will become 1. And finally you are left with this. V naught T into root of 2 into 1 minus sin theta. So V naught is 25 into I think 1.7. Yes. Into root of 2 into 1 minus sin 60 root 3 by 2. So 25 sevens 175. 25 sevens 175 and 25 ones are 25. 42. 42.5 into root of, yes, 2 minus root 3.3. Please check. 2 cancels. 2 minus 1.7.3. So this will be nearly coming out to be 22 meters. So solve using vectors, we can easily solve it. Next is a standard question. Two particles move in a uniform gravitational field. Two particles move in a uniform gravitational field with an acceleration g. With an acceleration g. At the initial moment, the particles were located at a particular point and move with velocities. V1 is equal to 3 meters second inverse and V2 is equal to 4 meters second inverse horizontally in opposite directions. This you might be knowing. Horizontally in opposite directions. Find the distance between them at the moment. Standard concept. Find the distance between them at the moment when their velocity vectors become mutually perpendicular. When their velocity vectors become mutually perpendicular. So this is the trajectory of the second particle. This is the trajectory of the first particle. It's a case of horizontal projectile motion. So at a particular instant, because the vertical height through which they are falling is same, hence the times are same. Therefore, these are the velocity vectors. So this is V1. Let us call it as V01, V02. This is V2. So if you extend them backward, somewhere the angle between them will be 90 degrees. So it is given V1 bar dot V2 bar is 0 since V1 bar is perpendicular to V2 bar. So the final velocity in the case of a horizontal projection is given by V0 into I bar plus GT into J bar. How you get this? I'll put in a simple way. Initially, at the highest point, it has only V0 x is equal to V0. At this point, it will have both horizontal as well as vertical components. So Vx will remain V0, whereas it acquires a vertical component of velocity GT. So this is the velocity after a time t seconds. So V1 bar is V0 1 bar, V0 1 into I bar plus GT at J bar. And V2 bar will be V0 to I plus GTJ. Substituting using, keeping it in this, we'll be getting finally T is equal to root of V0 1 into V0 2 by G. So it is root 12 by 9.8. So this is 4 into 3, root 3 by 4.9 seconds. And the distance between their displacement, separation between them, it is relative velocity multiplied by time. So it is relative velocity, because they are moving in opposite directions, V1 minus of minus V2, V1 plus V2, T, root V1 V2 by G. That's all. So nearly it will come out to be V1 plus V2. Yes, 3 plus 4, 12 into root 3 by 4.9 Nearly it will be, yes, 2.5 meters.
Completed, sir.
Good. Another point also may come. Suppose this is the point where they are reaching the ground. This is, say, O1. This is O. This is A. This is B. These are the lines joining the point of their projection to the point where they are located. Then they are inclined at 90 degrees. They are inclined at 90 degrees. So in that case, you will be getting it as time of flight for the position vectors joining the point of projection to the points where they strike the ground will be at right angles after a time equals to, yes, this is 2 V01 V02 by G. That's all. That can also come in the exam. Okay. A radius vector at a point A relative to the origin radius vector at a point capital A relative to the origin varies with respect to time as 18 to I bar minus bt square into j bar. 80 I bar minus bt square j bar, where A and B are constants. They can ask it as a linked comprehension type of question, or any one parameter can come. This same thing will never come. Any question based on this model. Now, where A and B are constants. Find first one, the equation of trajectory. We have written already for projectile y is equal to some tan theta into x minus g by 2u x square into x square. That is the equation of trajectory. You should write the equation for this problem also. Next, velocity and acceleration as a function of time. Third, angle between velocity and acceleration at any given instant. Alpha as a function of time. And fourth one, mean velocity vector averaged over the first t seconds of its motion. Mean velocity vector averaged over the first t seconds of motion and its magnitude. So this is how we'll begin the problem. R bar, you know, position vector in terms of coordinates, xi plus yj, such that x is equal to ux into t. Here it is given as at. Comparison implies ux or v naught x. Anyway, it's okay. Ux is equal to a. Of course, is equal to u because horizontal component of velocity remains constant. From this, you can put t is equal to x by u. That is x by a. Why you need it? Because same method for the equation of trajectory, y is equal to uyt minus half gt square. There in place of t, we put x by ux. In a similar method, we are trying to attempt. The next one is y is equal to, it is minus bt square. Now I can compare it with minus half gt square. So there is no initial velocity. So from this I can put g is equal to 2b. And the horizontal, this is second. The horizontal projectile equation of trajectory is ascending journey, it is minus g 2u square multiplied by x square, because here uy is coming out to be 0. Y is equal, suppose at minus bt square means uy is there, but here y is simply minus bt square. Therefore, uy can be assumed to be 0. Hence, it is a horizontal projectile. Equation of horizontal projectile is minus g by 2u square into x square. So, substitute this x in this, and finally I'll get y as minus b by a square into x square. In terms of a and b, we got. Next, b bar, vxi bar plus vyj bar. So here, x is equal to ux into t. Vx is dx by dt. So a. Vy is dy by dt. Y is nothing but minus bt square. So you'll get minus 2bt. Simple. Only thing, looking at the equation, many students will get disturbed. Right, what is this? Nothing. Only we have to add mathematics to physics. So we'll get v bar is equal to ai minus 2btj. That's all. So velocity as a function of time we have shown. And this is more easier. A bar d by dt of v bar. A is a constant he has given in the problem itself. So it is minus 2bj. That's all. So second bit also is over. Because x component is not there. This is entirely along negative y-axis, of course. Y-axis. So then it's more easier. Tan alpha will be A by 2bt. With, of course, y-axis. And last, V bar, we have AI, average velocity, AI minus BT J bar. So horizontal component of velocity will not change, it remains constant. So AI minus BT J bar, initially 0, finally it is minus 2bt, therefore it is minus bt. Now magnitude of this average velocity, it is simply root of a square plus b square t square. So looking at the equation, I should never get disturbed. That's what I wanted to emphasize. All will be standard concepts only.
Completed, sir.
Yeah, good. Take the next question. A point moves in the xy plane. A point moves in the xy plane according to the law x is equal to a sine omega t and y is equal to a into 1 minus cos omega t. Where a and omega are positive constants. Where a and omega are positive constants. Find number 1. The knowledge what you gain out of doing these problems must help you to attempt the competitive exam questions. That's what I always emphasize. If I say that, yeah, same thing will come in the exam, I am fooling you. I never do that. Whatever we do will never come in the especially advanced exams. You must use the knowledge gained in these classes to use, do it on your own. Yeah, find number 1. Distance traversed by the point during the time t seconds. Distance traversed by the point during the time t seconds. Also find the angle between velocity and acceleration. Also find the angle between velocity and acceleration. Otherwise, suppose if you don't get this idea in this problem, simply you put v bar dot a bar is equal to va cos theta. That way also you can do. So x is equal to a sine omega t, y is equal to a into 1 minus cos omega t. So here, Vx dx by dt, integration and differentiation should be eloquently used without any hesitation. A omega cos omega t. Ax will get the similar equation in simple harmonic motion. Minus a omega square sin omega t. You'll also write it as minus omega square x. Because x is a sin omega t. Vy dy by dt. A is a constant, you can mention. So it should be a omega sin omega t. Why? Because already minus sign is there. D by dt of cos omega t is minus sin omega t into omega, and this a constant will become 0. So that's how minus of minus will become plus. A omega sin omega t and ax will be a omega square cos omega t. So x and y are the instantaneous positions. Vx, ax, vy, ay, instantaneous velocities and accelerations in two mutually perpendicular directions. Therefore, we get the instantaneous speed or the magnitude of velocity is root of Vx square plus Vy square. So it is Vx a omega cos omega t, Vy a omega sin omega t. So it is a omega into root of sin square omega t plus cos square omega t. Anyhow, it becomes 1. Therefore, it is a omega. Recollect it with circular motion. V maximum is equal to R omega. Just like that, you can remember. And because the magnitude of speed remains constant here, so it should be V into T. Therefore, A omega T. Then acceleration. It is, yeah, already we have AX and AY. So AX square plus AY square, you will get A omega square. Then V bar, Vxi bar plus Vyj bar. So A omega into sin omega t I cos omega t j. Next. Correct? I think we wrote other way. Vx will be A omega cos omega. So V bar is A omega, I am taking common, cos omega t I plus sin omega t j. A bar A omega square into, yes, minus sin omega t I plus cos omega t j. So this will be coming out to be 0. To take dot product, this will be coming out to be 0. If the dot product of any two vectors is coming out to be 0, then theta will be equal to pi by 2 radians or 90 degrees. That is, V bar is perpendicular to A bar. Simple. Whenever the body is moving in a circular path, This is the direction of velocity. This will be the centripetal acceleration. So angle between them is 90 degrees. So the dot product becomes 0. Yeah, next question, you should tell me the answer without thinking much. So we did circular motion also to some extent. That radius of curvature, radius will actually a part of circular motion. But I worried when we talk about centripetal force, banking and all, we may miss this concept. That's why I am doing here itself. See, for a first year student, it will be difficult. Array, we have not done those topics. It may be difficult for them. You completed everything. That's why I am taking this liberty. Completed, ma?
Completed.
Good. Girls? Manaswini and Chandana.
Completed, sir.
Good. Yeah, next problem I expect that. Oh, sorry. What I did? Shit. Okay. A particle moves in the XY plane. A particle moves in the XY plane with a constant acceleration. With a constant acceleration. Yes, given it as omega. Directed along the negative y-axis. Directed along the negative y-axis. The equation of the particle, the equation of the trajectory of the particle, the equation of trajectory of the particle is in the form y is equal to ax minus bx square. Where a and b are positive constants. Find the velocity of the particle at find the velocity of the particle at the origin of the coordinates. So for this projectile, of course, assuming that it is on the earth, we can take g is equal to omega. Of course, in vector form, g bar minus omega into j bar, because he says it is in negative y direction. And v naught bar is v naught xi plus v naught yj. And this equation resembles y is equal to ax minus bx square. That is tan theta into x minus g by 2u x square into x square. So minus g is here nothing but omega. Then we'll get a is equal to tan theta. So this is a, this is 1, this is theta. Then this will be root of a square plus 1. So cos theta is 1 by root of a square plus 1. Then b will be omega by, yes, 2 v naught square cos square theta. So from this, v naught square is omega by 2b cos square theta. Omega by cos theta is 1 by root of a square plus 1. So it is omega into a square plus 1 by 2b. So v naught is root of omega into a square plus 1 by 2b. Same thing I told you in the beginning. G into a1 plus a square by 2b. Same thing. Why I did this? Because definitely in spite of doing it, students won't get idea in the exam. Maybe some intrinsic tensor and intrinsic tension cropping up in the minds will prevent them from thinking further. So that should not be. And then standard models like, must try them. Completed, huh?
Completed, sir.
Okay. So these questions, 3 particles are at the 3 corners of an equilateral triangle of side A. Each is attempting to approach the other with same velocity v naught when and where they meet. So they will be meeting at the centroid, no doubt about it. When means the magnitude of displacement of each particle will be equal to BO. This is nothing but 2/3 of median. Median of equilateral triangle is root 3 by 2a. Therefore, this becomes a by root 3. And velocity, this total angle is 60. So, velocity along BO or AO will be V cos 30. So, it becomes root 3 by 2a. So, time after which they meet, displacement by velocity in that component, in the direction, a by root 3 by 2a root 3 by 2v, sorry. So, hence we will get 2 by 3 into a by v. That's all. Same question if it comes like 4 particles are at the 4 corners of a square and each is trying to approach the other. So this will be root 2a by 2. A by root 2 will be the displacement and this angle is 45 degrees. So it becomes V cos 45. So time will be a by root 2 by V cos 45 degrees. So simply T is equal to E by A by V. Even this is also very, very important model. Okay. Completed, ma?
Yes, sir.
Okay. Then when two bodies are projected at complementary angles, they will have the same range. Maximum heights are different. Times of flights are different. This is theta 90 minus theta. You should be knowing it, but still as a precaution measure because this is very important. You can expect some questions based on this. So R will become half G T1 T2. Here T1 is 2u sin theta by G and T2 2u sin 90 minus theta 2u cos theta by G. So range will be half G T1 T2. And you know heights H1 u square sin square theta by 2G. H2 u square sin square cos square theta by 2G. Sorry. So same range formula can be written as R is equal to 4 into root of H1 H2. And then some more things which you need to remember. H1 by H2 tan square theta is equal to T1 by T2 whole square. Next, H1 plus H2 u square by 2G is equal to T1 square plus T2 square. Am I right? No. Because that sin square theta plus cos square theta will become 1. H2 minus H1 will become u square by 2c into cos 2 theta. Next, in case of a projectile, for a projectile, h by r maximum is 1 by 4. So this is the maximum range, and a body is projected vertically up with the same velocity. So this is h. Then the height, this is called as h naught. So h naught by r maximum will be 1 by 2. So many students will confuse. H is the height of the projectile. So h by r max is 1 by 4. He says a body is projected with the same velocities. Two bodies are projected with the same velocities. Already we did one model based on that. One with an angle of 45 degrees, other in vertically upward direction. So the ratio of maximum height reached by the vertically projected body to the range, 1 by 2. The ratio of height of the projectile to its range, 1 by 4. So all small things you must practice. And tomorrow, we'll do that projectile motion on the inclined plane, followed by laws of motion. Laws of motion, mostly I focus on constrained equations and friction. Right, Ma?
Okay.
Okay. So I'm concluding my class.